In this video, we're going to talk about how to determine holes in rational functions. So some rational functions will have holes, and that'll be a point at which the function is not defined. And the reason we have these holes is because some values of x will make both the numerator and denominator equal to 0. So holes are actually considered to be removable discontinuities because what happens is if that hole was actually defined, your function would be continuous. A quick way to see holes is that if you see this common factor in the numerator and denominator, that's going to tell you the location of the hole. So what we're going to do in order to determine these is first factor the numerator and denominator. Then you look for the common factors, and the x-coordinate of the whole can be found by setting the common factor equal to 0 and solving for x. Then what we're going to do is take that x value and plug it back into the simplified function that we have after canceling the common factor, and that will tell us the y-coordinate of the whole. And you'll be able to see the hole in Desmos, but if you look at the graph, it won't show up. If you click on the point where there's supposed to be a hole, it will tell you that there is in fact a hole there. So let's determine the whole of f of x equals x squared plus x minus 12 over x minus 3. So the first step is to go ahead and just factor this function. So we have f of x equals x plus 4 times x minus 3 over x minus 3. Okay, so notice I have this common factor here. I have this common factor of x minus 3. So what I'm going to do now is I'm going to take that x minus 3 and set it equal to 0 and solve for x. So that gives me x equals 3. That will be the x-coordinate of my whole. So in order to go ahead and figure out the y-coordinate, I'm going to cancel the common factor, and that's going to give me f of x equals x plus 4. So now I'm going to take this 3 and plug it into this simplified function, and that's going to give me the y-coordinate. So I have 3 plus 4, which is equal to 7, so that means that this graph has a hole at 3, 7. And what you can do is you can graph this function in Desmos to verify there is in fact a hole there. So when you look at it in Desmos, you won't see it, but when you click on it, you'll see the point change to like an open circle, and then it'll say 3, undefined, and that is how you know there's a hole at that point. So now let's try this example. So in this one, once again, we want to start off by factoring everything. So the numerator will factor into x plus 6 times x minus 1. And then if we factor the denominator, well, there's a GCF there, right? So from x squared and x, we can factor out an x. So that gives us x times x minus 1. So notice once again we have this common factor of x minus 1. So let's go ahead and set that common factor equal to 0 and solve for x. So when we do that, we get x equals 1. Okay, so let's go back here. We need to actually figure out the reduced function now after canceling the common factor. So that's going to give us f of x equals x plus 6 over x. So when I plug in 1, I get f of 1 equals 1 plus 6 over 1, which is equal to 7 over 1. And so that once again has a y-coordinate of 7. So the hole on this graph is going to be located at 1, 7. And once again, if you go to Desmos and graph that, you'll be able to see the hole. So now you can go ahead and pause the video and try doing this example on your own. So here, when we factor the numerator, it has a GCF of 2, okay? So we can go ahead and factor that out. And then we have x squared plus x minus 12, which factors into x plus 4 times x minus 3. The denominator is the difference of squares, so that factors into x plus 4 times x minus 4. So when you plug the factors back in, you notice that we have a common factor of x plus 4. So we can go ahead and set that equal to 0. That gives us the x-coordinate of the whole, which is negative 4. Once we have the simplified function, we plug in negative 4 back in, and then that gives us a y-coordinate of 7 over 4. So the whole will be at negative 4, 7 over 4.